Let's find the standard form of a quadratic function together. Let's get started. Find the standard form of a quadratic function with its vertex at the point 9, -6. And the function passes through the point -7, 2. The standard form of the quadratic function formula is listed in the problem. So let's review what we have. We have a vertex of 9, -6. We know that the function passes through this point, -7, 2. And we have the formula. When we want to write the quadratic function in standard form, we need to list three variables, a, h, and k. We need to replace those, substitute them in with their values. We are going to rewrite this function notation into equation notation. So we're going to let f of x equals y, since y is a function of x. Now we are going to review the given information. The parabola passes through this point. This is a point on the parabola. So these coordinates represent x and y. X equals -7, y equals 2. The parabola also passes through this point, but this is a special point. It is the vertex, and the components or the coordinates of the vertex are represented by h and k. H and k. So now we know that h equals 9 and k equals -6. So let's go ahead and list out what we know. H equals 9, k equals -6, x equals -7, and y equals 2. So in this standard form of the quadratic function, there are 5 variables. We know 4 of the 5 variables. We know y, x, h, and k. A is unknown. So 5 variables, we know 4 out of 5. We're going to substitute those 4 values in, and that will allow us to solve for the 5th and unknown variable a. So we're still searching for a. Let's substitute y for its value 2. We're going to rewrite a, still unknown. Just going to rewrite the components of the formula that are going to remain the same. Now let's substitute in x for the value -7. Substitute in h equals 9. And finally substitute in k equals -6. Now that gives us 2 equals a times. We're going to focus in on the parentheses first. -7 minus 9 is -16. And we will clean up these signs, subtract a negative, or actually add a negative. Add a negative becomes -6. Now, let's focus on the exponent. -16 squared means -16 times itself. -16 times -16 is positive 256. Now we have 2 operations on the right preventing a from being alone, and we want to isolate a. We have times 256, and we have subtract 6. We're going to focus on eliminating subtract 6 first, then we'll go and eliminate the times 256. The opposite of subtract 6 is plus 6. We will add 6 to both sides to maintain the balance of this equation. this becomes 8 equals 256 times a, and 6 take away 6 is 0, so that term is gone. Now the opposite of times 256 is divided by 256. We will do that on both sides of the equation for balance. And now 256 goes into both of these numbers evenly, one time each. On this side, 8 will go into both of these numbers. 8 go into itself once, and it goes into 256 evenly 32 times. So we're left with the fraction on the left, 1 over 32. We cannot disregard this numerator of 1. Numerators of 1 are not understood. We have to keep it. And on this side, we have 1 over 1, which equals 1. 1a is simply a. So we have found what a equals. A is 1 over 32. So now we have the three variables that are needed to plug in to write this quadratic function that we're looking for. F of x equals a times the quantity x minus h, quantity squared, plus k. We're going to substitute in a, h, and k. F of x equals a equals 1 over 32 times the quantity x, take away h. H equals 9, close parentheses, all squared, plus the value of k, negative 6. And again, we're going to clean up those signs. F of x equals 1 over 32 times the quantity x minus 9, quantity squared, minus 6. And we have found the quadratic function in standard form with a vertex of 9, negative 6, passing through the point negative 7, 2, 2. Thank you for tuning in to Math Made Simple with Professor Vernette.